So in this video I will have another example of a formula that I will prove by induction. In the last video I called it induction proof, but I didn't know that it was called proof by induction in English, so I changed that now. In this video I'll be covering a sum that looks like this. I equals 1 to n of I squared, which can be written like this: 1 squared plus 2 squared plus 3 squared plus and so on up to n squared. And this is supposed to be n times n plus 1 times 2n plus 1 divided by 6. So this is what we know, and this is what we are going to prove. So I'm gonna call this formula right here S as a function of n, S for sum, as a function of n. So first I have to prove that it holds for n equals 1. So then I put 1 in the sum right here instead of n. So then I just have to put 1 into this formula to have to check if the sum from I equals 1 to 1 of I squared is equal to S of 1. So see here that I only take the first term in this sum, so then I get 1 is equal to, and as in the last video I'm asking myself if they are equal. If they are, the formula holds for n equals 1. So I put it equal to this formula, but I substitute the n with 1. So I put 1 here, I put the 1 there, and 1 there, times 1. So 1 is supposed to be equal to 1 plus 1, that's 2. So 2 times 1 is 2, plus 1 is 3, so 2 times 3 divided by 6, which I know is 1. So the formula holds for n equals 1. So now is the next step, which is called the induction step. I have to check if the formula holds for n equals k plus 1. So what I do here is take this sum right here, and I find a formula for n equals k first. Which should be the same as this, except the k instead of the n. Which is supposed to be the same as this. I just substitute the n with k. And then I can find the formula for n equals k plus 1. So the formula for n equals k plus 1 will be S of k plus 1, and then I put k plus 1 here, and instead of this n right here I put k plus 1, and instead of this n I put k plus 1. So this is the same as k plus 1 times k plus 2 times 2k plus the 2 times 2 plus 1 is 3. So 2k plus 3 divided by 6. And the sum will be this with the k plus 1. So I can say here substitute for n equals k plus 1. Then I put k plus 1 here, and then I put k plus 1, and this whole thing is going to be squared. And that's supposed to be the same as this. But I already assume that this is the same as this. So then I just can put this term instead of this right here. So then this, which I assume is the same as this, I substitute that, and then I take this last term, which is supposed to be equal to this formula, as of k plus 1. So now I'm asking myself if these ones are equal. So what I'll do here is I'll use some algebraic methods to see whether or not these are equal. So what I'll do next is multiplying this with 1, which is the same as 6 divided by 6, so I can add it into this fraction right here, which has the number 6 in the denominator. So I start copying this line, and I multiply this with 6, and then I divide it by 6. And this can also be written as 6 times k plus 1 times k plus 1. And now I see that this term right here has 6 in the denominator, and this has 6 in the denominator, and this has k plus 1 in the denominator, and this has k plus 1 in the denominator. So I can factorize those. So then I take k plus 1 divided by 6 and multiply that with. So then what I have left is k times this goes away and this goes away. So that's 2k plus 1. 2k plus 1. And what I have here is this goes away and this goes away. So what I have is 6 times k plus 1, which is supposed to be equal to this. But here I can also factorize k plus 1 divided by 6 outside. And then this disappears, and the fraction disappears. So now it may seem that we're very far from the end, but there's only a couple of algebraic methods I have to use left to find that they are equal. So I divide the whole equation by k plus 1 divided by 6. So just take that away, and then I take this multiplier away. So then I only have this term and this term left. So I multiply this k into the parentheses, and I get 2k squared plus k. 2k squared plus k. Then I multiply the 6 into the parentheses, and I get 6k plus 6, which is supposed to be equal to, and then I multiply these parentheses together, then I get 2k squared plus 3k plus 2 times 2k is 4k plus 2 times 3, which is 6. And then we see that these two are looking very similar. So k plus 6k is 7k, and 3k plus 4k is 7k. So no question mark needed, these two are equal. So what you say is the formula holds for n equals 1 and n equals k plus 1. Therefore, it holds for all n by induction. Thanks for watching. Click the annotation in the corner to watch the previous video, and subscribe if you want to see similar videos in the future.